Here's part 2 of 3.3, very short video. We are literally just going to be reflecting over y equals x. And so reflecting over y equals x is essentially reflecting over the line that goes through, right, the diagonal line that goes through the coordinate plane. So y equals x, and we graph that. That looks like this. Okay, sometimes you'll have y is equal to negative x. You'll have to graph that, and it's pretty much the same, except it starts from up here and goes downward, whereas the other way around, we started from down here and went upward. Okay, so there's different rules for y is equal to x versus y is equal to negative x, but it's a very small change in the difference. And we'll discuss that in class. All right, so the reflection over y equals x. In this case, we're going to reflect a triangle ABC over the line. Y is equal to x. And so it's a little bit different, and in some cases a little bit more challenging, but pretty much the steps are the same. The rule is very easy to remember. As you can see, it's just flip the coordinates, okay? But we're going to apply the same practice we did to the others, where we look at the line of reflection and we determine, well, how far away from this or how many units away from the line of reflection is this? And here it's about, half a unit. So half a unit away here, so you would end up with C prime right there. And what are the coordinates of that? Well, the coordinates of C are 4, 1, 2, 3. So -4, -3, and in this case, they are -3, -4. So as you can see, we literally just switch the order of the x and the y values. And then how about B? So B is right here, and let's count how many units away. 1, 2, and because it's diagonal, it's kind of hard to do. But let's try it anyway. 1, 2, 2.5, so a half, 1, 2, and I think it would end up right here. I hope I'm correct. So let's check it out. 1, -4. Okay, yeah, I was right. Because based on the rule where we're flipping the sign, 1, -4, the original is -4, 1. So, sorry for shaking the camera. 1, -4, that's B prime. And then count the amount of units away from the line of reflection. A is 1, 2, 3, 4, 5, 6, 7. All right, 1, 2, 3, 4, 5, 6, 7. Oh, that doesn't look like it makes any sense. So I'm going to actually look at these coordinates, -10, -3, and then flip them, 3, -10. All right, because I think I was supposed to do this 1, 2, 3, and a half, 1, 2, 3. That makes more sense. I was doing it the wrong way before. So then A prime would go down here, okay? And connect those. And so the coordinates of A are -10, -3. I'm sorry, -3, -10. Okay. Alrighty, so what pattern do we notice? Well, we switched the order of the coordinates. That's the pattern that we noticed. And you are going to be responsible for doing this one on your own. We're not going to do that together. Do that on your own. I'll check it. And then do the try it out on your own. The trick with the try it out is, or rather the thing that might confuse you about the try it out, is the fact that there are 2 points that are on the line of reflection. Whenever that happens, keep in mind those points do not change. Okay, now if they are asking you to graph the reflection of the line x equals 1, then you are going to draw in that as your line of reflection, okay? So your line of reflection is x equals 1, which would be here. Okay, and so now you need to reflect this over the x equals 1 axis, okay? And now if you think about it, you're just going to count how many units away is B, okay? 1 unit away, so count 1 unit to the right. Same thing with A, same thing with C, all right?